The following content has been provided by RWTH Aachen University.
For now, I want to talk about if we know that these errors are there, what can we do in software to protect them? We've already seen that modes may be not a good idea, so if you can avoid those, that's good. But slips are easier to detect than mistakes because they are just things where the user will immediately realize that something's wrong if we alert them to it. But we need to provide feedback. One example that I think Norman talks about in his book is, driver is driving and he says to the passenger, "Oh, can you adjust the window, please?" And the passenger's like, "What?" And then, of course, what you do is you say the same thing just louder, "Adjust the window." It's like, what do you mean adjust the window? And then after some point, the driver realized that what she was really trying to say is like, adjust the mirror, right, not the window. So just a mismatch, saying something wrong. But this only works because you get feedback from the other person that they're not understanding you or asking you to explain it differently or something like this. And similarly, a computer should help catch these slips, these things. Action-based slips are a little easier to detect than memory ones because the feedback is tangible, right? You've done something and you see the immediate feedback of it. Mistakes, like I said, are hard to detect because everything went great except the goal was wrong to begin with, and that's hard for the computer to determine, of course. One problem that you'll have when you're trying to fix things is that you need to find the right level at which you help the user to correct their slip or their mistake. And it seems to suggest, psychology seems to suggest that we are doing this correction of mistakes bottom up. There's the story where, and maybe you've been to this yourself. You walk to the parking lot and go to your car, and you insert your key in the car. Before there were only remote controls, and it doesn't fit. So first thing you try is, got to turn the key maybe the other way around. Maybe it's one of those evil keys that fits both ways but only works one way. So you try that. That also doesn't work. And then you're like, oh, maybe it's the wrong key. So you look through your keys and your keychain and try a different key. And only after you've tried all these things, you realize, oh, that's not even my car. Yeah. So we're basically trying to fix things in a small way first, and then we question more and more larger assumptions about what we think is right in order to find where we went wrong. Now, of course, the standard answer of a computer programmer to mistakes by the user is, oh, I'll just put in a confirmation question, and then the user will, of course, only confirm and say yes if they really, really mean it. And we also all know that that doesn't work, right? Those like remove file so-and-so .text, yes or no. I mean, that's just becomes second nature just to hit yes after your delete command. And so those things don't really catch errors. It's a better idea to make actions reversible. The trash can of every graphical user interface on the desktop is a good example of that. I can throw stuff away, and there's no extra command that asks me, are you sure you want to delete this? But if I go wrong, and I notice it right now, or even a day later, I can still pull stuff out of the trash can and fix those mistakes. The problem, of course, is that people begin to rely on that. Right? So then now people are putting stuff into the trash can all the time and thinking, like, I can always get it back. Now they need to empty the trash can, and now you got to put up big alerts saying, like, well, that means you will delete. And it doesn't help to say, are you sure you want to enter the trash can? Because, hey, that's what they just said they want to do. Instead, it makes much more sense to say, there are currently 147 files, 73 folders, 2.5 gigabytes of data in the trash can. The last file you added was this one. You sure you want to delete all this? So give people some context. Give them a way to reflect on what they're going to be doing, the action, from a different point of view. That could help. Automation. Remember the story about the film projector, right? Where the threading of the film got easier because the system did it. The problem with automation is it's great because it takes care of the task as well as the user, or maybe even better. But it can take over dull, repetitive, simple tasks. But if things get complex or specific or out of hand or problematic, if there are exceptions to the rules, then automation breaks down, and then it leaves things to the user again, and then it becomes really difficult or maybe even dangerous. Self-driving cars are a good example of that. Just driving down an empty road, easy enough for a computer, but the difficult situations were like, there's a ball running, and there's a dog, and then there's like, I don't know, a tree falling down, all this kind of stuff, maybe happening at the same time, I don't know. That's where automation will blow up, and then you need to think about how you're going to capture that. So how can we design for error? Well, first of all, we can assume that all the possible errors that we kind of maybe get a first understanding now from the slips and mistakes discussion, all these errors will be made by users. And they will make a couple errors that we cannot even imagine. Right? That's very, very clear. You should minimize the chance of errors occurring, minimize the effect that the errors have if they are made, and make them easy to detect and easy to reverse with things like undo or soft reversible actions. Watch your people using your system and watch them with their slips and the mistakes that they tend to make, and don't punish them for the mistakes and don't ignore these mistakes. Warning signals are like, are you sure you want to do this, are usually ignored, and warning features are usually bypassed if they are inconvenient. I'll close this with a couple examples. Wonderful message. Operation could not be completed. If you want to know why, it's because of client error not possible. Right? Very clear. Or I like this one too, from an image burner application. You should have selected the Q file and not this one. I'll do it for you automatically this time, but don't do it again. That's like typical approach of a developer. Okay, we're going to finish here today because we're out of time. Next week, we will close the book on Norman. So this is the last week that we will be talking about Norman stuff. We'll close next week with some principles for design, and then we'll move beyond the book. Okay, so finish reading it if you haven't already. Thank you.
This content was provided by RWTH Aachen University.